streaming webinar of FoodSense. So not now, but in about 5 to 10 minutes, my colleague Solron will do that live streaming webinar. But hopefully I'm coming through clearly, and don't forget, and don't worry, we'll record anyway. That said, just to say that anyone who actually gets a FoodSense will get personal online training. So we can obviously use these kind of technologies to show you what we're doing in the lab, and that's and you can follow along, or you can but also to say that we do weekly webinars on FoodSense as well. Now what I mean by that is this is really a demo and webinar, so we'll do some live streaming demos today. But then when people have questions, so somebody just got hold of a FoodSense and they have a question, then we do weekly webinars. So I just want to say that in August, for example, we have 5 webinars organized. August seems to be a particularly long month. So we have the 2nd, the 9th, the 16th, the 23rd, and the 30th of August. They're all booked in. And any questions that then come in from new users of FoodSense, we'll cover them in the webinar. So that will happen every Wednesday at 8 a.m. London time, and they're all booked in as well. So you can at least expect a video response in the week. Just a quick introduction to Zimmer and Peacock. So just to say that we were formed in 2014. We are ISO 13485. So I think we actually hold ourselves to a higher quality standard than a lot of companies, because a lot of what we actually do is in the medical space. But so we are ISO 13485, and we're contract developers and contract manufacturers of electrochemical sensors. As it says here, we have R&D facilities, and we also have manufacturing facilities. So I will cover those. We're primarily based in Norway and the UK, though we do have strong sales in India and obviously the USA and in Europe, Asia more in general, Australia, etc. So we're quite global in our reach. The team is global and international in makeup. So I think there's 23 languages spoken at Zimmer Peacock. I did say, that we have multiple sites at ZP. So this is our manufacturing facility. It's about a 4,000 square meter. I'll just whoops-a-daisy. Yep. So I think we've got an extra person in now. So I'll just do a quick summary. So Zimmer and Peacock, we're ISO 13485. We mainly do contract development, contract manufacturing. We have multiple sites around the world. New customers of FoodSense, we do a private demo and training when you first get the hardware, and also weekly we do a Q&A session where we just answer questions that came in from the user base during the week, and we do anonymized results or anonymized replies, and we put the data up there and show images or make videos, etc. So this is our manufacturing facility. This is our R&D facility in Norway. This is our R&D facility in Coventry, so we're quite near Warwick University. And this is a little satellite office that we have at a university called Swansea in the UK. I'll come off talking about ZP and talk about FoodSense. So FoodSense is primarily, it's used for actually measuring the hotness of chilies, chili sauces, whole chilies. We've got videos up on all those kind of different matrices, but really you could just call them samples. The background to this is there's a guy called Professor Richard Compton. He's at the University of Oxford. I'm not sure if it's St John's. I think he's actually at St John's College. And he first sort of invented this technology easily over 10 years ago now. And we became aware of it because there was so much media interest at the time, because I think, it kind of it gathers the media's attention, chili sensing, it sounds like fun science. So the media sort of jumped upon it. Now, what we are measuring is capsaicin. So if you get a bottle of capsaicin from a chemical supplier and taste it, the first thing is you don't do that. But the second thing is that's got a score of something like 16 million Scoville heat units. And I do want to say that even if you're joining late today, don't worry about it, because we've got a list of everyone who wanted to attend today. And so we'll take that list, and I'll send out I'll edit this video and send you all a link anyway. But anyway, back to the point. Capsaicin is the molecule that gives you the sensation of hotness. In its neat form, it's got a score of about 16 million Scoville heat units. Now, Richard, as I say, is this professor at Oxford, St John's College, Oxford. And in his original paper, he used a technique called voltammetry. You will see this happen today as well, but we don't show you this raw signal. The reason that we don't show you the raw signal is because, well, really, because it's it's highly scientific, and we really want to turn it into something that's more meaningful, like Scoville heat units. But what's happening is when we start this assay, we're doing voltammetry, and you'll see in this voltammetry that there are peaks, and the peaks are very indicative that this is actually capsaicin. So if I let it run now, what you'll see is this is a peak. That peak is kind of telling us that that's probably capsaicin. But then you'll see that there's another peak that the instrument generates, which is here. So that's the second indicator that we actually have capsaicin. And then we do a new, we call it run. We do a new run and we get a new peak. So that's 3 peaks. So those 3 peaks are indicative that there was capsaicin. And then the area under the curve is how much capsaicin is actually in that sample. So we were able to do identification and quantification. And that's what the original paper from Richard was. And that's easily over 10 years ago now. So I'll kind of go forward now with a bit more of the product. So if you're measuring the hotness of chilies, obviously people are using HPLC. This is clearly not a perfect solution for people. And I think it's because the instruments are very expensive. You've really, the instrument's expensive. To get it tested by a third party is very expensive. And so people are probably most of the time not doing it at all, or they're doing it very infrequently. So this is an HPLC system. I think people are not really doing panel testing. I think what's really happening is the quality manager in the particular chili facility, let's say, or chili production facility, is actually tasting these chilies. Or but then, of course, then there's FoodSense. And so FoodSense is trying to be objective in the same way that the analytical testing, the same way HPLC is. So you can do subjective testing. It's really hard to support and defend the product when the customer in the UK, this is often the supermarkets, complain that their customers say it's hotter or milder. It's very hard to defend it because you have no objective measurement, because you probably the margins sometimes in the food industry are such that you can't actually send samples every time for HPLC, or it's too expensive to run HPLC. But at least with FoodSense, you get an objective result, which means you can prove your repeatability of your product. So this is an objective measurement. The FoodSense, I mentioned that we are ISO 13485. So our quality systems are mostly geared up for the medical space. So I think we're held at a higher quality standard than many other manufacturers, because what we help people do is what's called in vitro diagnostics. So if there's anyone in your circle of friends or family or colleagues who has diabetes and they're testing their blood, you'll notice the similarities between that and what FoodSense is. FoodSense has a meter, has a little strip, and we have apps, but it's an electrochemical measurement. So most blood glucose measurements are actually electrochemical, and this measurement of capsaicin in these samples is also electrochemical. So electrochemistry is a technique that allows you don't have to overly prepare a sample in order to take a measurement. You can put a drop of blood on a glucose strip and it'll give you a result. One of the expenses of HPLC, high pressure liquid chromatography, is actually you have to really prepare that sample. So there's a big sample prep, and then you have to run the sample itself. But you'll see that the sample prep is much quicker with the FoodSense. Now, we have at ZP, we do own an HPLC. So whenever you're developing a new assay, you sometimes want to compare it with what's already on the market. So we did actually test ourselves against HPLC, high pressure liquid chromatography. So we did it for ourselves, but then unbeknownst to us, there was also an independent academic study done as well by a guy called Charlie Rower at Minnesota University, and he also tested it. That paper, by the way, is yeah, I have put a link here. Like I say, I'll get this recorded, or rather, it is recording, and so that means you'll be able to rewatch this video afterwards and maybe find that link. But so Charlie actually did his own paper and said, no, this is actually quite good. Now, the reason he thinks it's quite good is because he was comparing against HPLC, but he could only afford one test on the HPLC when he was able to test the same sample 3 times on the FoodSense. So he was getting repeatability with FoodSense. With HPLC, you have no indication of how repeatable that result is. So he was really quite pleased with that. I mean, it's probably worth saying that we do get a lot of questions around HPLC. I want to say to one thing that if you send the same sample to 3 different labs, you will get 3 different results back. So be careful when you're trying to compare. When you're trying to analyze a HPLC result, a certificate of analysis that you get from a third party, you got to be careful, because if you send that same sample to another HPLC lab, I guarantee you'll get a different result. So 3 labs, same sample, 3 different results. So we do meet that quite a lot, that they say, oh, well, it's the certificate of analysis says this. Like, are you really sure? And most of the time people are not sure, actually. And like, we've got clients who are sort of billion-dollar businesses, and they do this. They test the samples at different HPLC labs, and they get different results. They know it. With smaller producers, that's not always so apparent to them. But as I say, you can actually send the same sample to the same lab and get 3 different results as well, by the way. So you can say that there's an intra-lab problem and an inter-lab problem. So HPLC is not the gold standard that people would otherwise think. I'll go a bit quicker now because we really want to get onto the demos as well. But FoodSense is in its, we're at 3rd generation 3 at this moment. It's really kind of matured over the years, as you would expect. And it's got very kind of robust. One of the things you'll notice as well is that when we're testing different hot samples, we're using different amounts of buffer. Like I say, if you drop out today, don't worry about it, because I will edit this and send you a video afterwards. But you'll notice we use different volumes of buffer. Now, the reason this is you'll see this demo anyway. But the reason for this is that capsaicin, I did mention capsaicin at the very beginning of these slides. Capsaicin is an organic molecule. It's actually not that soluble in water, essentially. So what happens is that if it's a very hot sample and therefore very concentrated with capsaicin, we use more buffer. And if it's a mild sample and therefore not that concentrated, we use less buffer. So we have a sort of rule of thumb. So it's probably worth saying that actually capsaicin is not very soluble in liquids, and it's only the fats and the oils that you add to products that actually allow you to solubilize all that capsaicin. Otherwise, it would be quite insoluble, and it would be in the solid state, maybe very small crystals, but it would be in the solid state. So what you'll see us do today is that if we've got a mild sample, we may do a sort of 1 volume of sample to 9 volumes of the buffer, if it's mild, because we kind of assume then, we don't need so much buffer in order to dissolve all the capsaicin in. But if we're doing something very hot, I mean, things like chili powders and chilies themselves, we'll actually do 1 in 100. It can get quite, and that's because, again, we know that capsaicin is not terribly soluble. Sorry, I'm going to cough. It's not terribly soluble, so we need more buffer. Now, what's going to happen in a minute is we're going to do some demos. So I will stop sharing my screen. I'll turn my camera off, and then my colleague Solrun will share her screen and share her camera. So let me do that. Thanks, Solrun.
All right. So yeah, my name is Solrun, and I will run a quick demonstration on how to use the FoodSense app. So what I will start doing is I will prepare my sample. The sample preparation is a crucial step of our testing. So I have the, I need to just put some gloves on. I have the FoodSense box here, and I will insert one of the FoodSense sensors, the Chilli sensors, into the FoodSense box. And when I insert that into the box, I'm making sure not to touch the electrodes of the sensor. Just not to scratch it or leave some contaminations on the sensor surface, on the electrode surfaces. So I will prepare a 1 to 10 mixture ratio of Tabasco sauce. And so what I will do is I'll pipette 1 milliliter of the CP chili pop buffer. And I will pipette that into the vial, just like this. So 1 milliliter of the chili pop buffer, and then I will add 100 microliter or 0.1 milliliter of the chili pop buffer. I will then get a mixture ratio of 1 to 10. So I'll just add some Tabasco sauce into the to the weighing shed like that, just so that it's easier for me to pipette it. Then I will pipette 100 microliter. Just need to adjust the pipette like this. And then I'll pipette that into the solution. So if you look at the close-up, you'll now see that the Tabasco is on the bottom and the buffer is on top. And what we will do now is we will vortex it. We'll use the vortex just because it's easier to mix it that way, it's quicker. Capsaicin itself is not very fond of, or it likes organic surfaces and organic components. So that's why we need to mix it so that we are sure to extract the capsaicin from the Tabasco phase into our buffer phase. So just like that, Tabasco fortunately is quite an easy homogeneous liquid, so it doesn't require that much mixing. And I'll show you, and now you see that it's all mixed up really well. So what I will do now is I will pipette 50 microliter of this mixture onto the surface of the electrodes. Then I will also get my screen going. Just give me 2 seconds. $50 microliters onto the surface of the electrode. And as I said, capsaicin do love organic surfaces, and yeah, so it will stick to the surface of the electrodes, which means that from the time you pipette the solution onto the surface and until the time you start clicking measure on the app is very crucial. Like, you need to keep that time consistent for every sample. Like, if you would leave some samples laying there 10 minutes before you start it, or in some samples for 10 seconds, they will differ. So what I will do now is you will see the app coming up on the screen. So this is the FoodSense app, and here you see the mixture ratio is 1 to 10. So I will now click measure, and the app will run, and it will take approximately a bit less than a minute. Yeah, and I will show you a close-up while it's running. I will show you a close-up of the solution onto the electrodes. So here, well, on screen here, you can see that there's like a bubble on top of the electrodes, just like that. And then I'll go back to where the app is running.
Okay, cool.
Yeah, so you see that the bar is, there's a progress bar, and what it's doing right now is that it's running through some cyclophotonograms, and it's looking at the peaks and the peak heights, and it's assessing the peak heights and correlating that to the amount of capsaicin in our sample, and also calculating the Scoville heat units based on that. And now we got the result back of 3,600 Scoville heat units, which is in the range of what Tabasco themselves claim that Tabasco is. And then I will also show you if you like, you can test quite a lot of different samples with the FoodSense box. Right. Okay, I'm back. Can you still hear me?
Yeah, we see you. Yeah, don't worry, but don't worry, we see you.
Perfect. All right, so Tabasco is a fairly homogeneous, easy sauce to test, but you can also test more chunky sauces. But that would just require some more sample preparation, or to allow the capsaicin to extract into the buffer. And so what I will actually do now is I will test some powder. This is just a chili powder with an unknown Scoville heat unit. And I've just cheated, so I've already rated out the powder, but here it says 0.1 gram of powder. And I expect this one to be more spicy than the Tabasco sauce. So for this one, I will prepare a mixture ratio of 1:100. So with that, I have 0.1 gram, and I will add 10 milliliters of the chili pot buffer. So I'll do that just now. I'll change the pipette. And again, the reason why we need different mixture ratios is just because there's like a saturation of the capsaicin in the buffer phase. So for more spicy, more pungent sauces and powders, we just like for there to be more buffer present, so we don't reach that saturation. Okay, so I'll add it into the vial just like that. I will show you what it looks like. Okay, so here you see all the powder is falling down to the bottom, and we won't worry too much about that. And then I'll just use the vortex to just change it up and mix it real well. And ideally, for a powder like this, I would maybe leave it on the bench for a couple of hours before I would test it, just to make sure that the capsaicin will really extract into the buffer phase. And I would also do that for some chunky sauces, and even overnight, but you just need to make sure that you're consistent in how you do it. So sometimes like an hour is enough. And sometimes I just leave them overnight just to make sure. But then a lot of times I see the same results for the ones that have been resting for an hour and resting overnight. It just depends on just how chunky the samples are. And now I'll show you again what it looks like after vortexing, and you again see that the powder is falling down to the bottom, which is totally okay. The capsaicin itself is being extracted into the water phase, so it's okay that we don't have that laying on the surface. So again, I will insert one of the chili sensors into the FoodSense box, and I will add 50 microliters of the solution. And if you get some chunks and bits into the pipette tip, which you pipette onto the sensor, that's okay. So I will just pipette, and I will see grains of powder and everything on the top of my surface, and which is totally fine. All right. And then I will hit measure, and now I will change the mixture ratio to 1:200 because I have a different mixture ratio now. So then I will start running it, and again it will run for approximately a minute. Just need to give it some time. And again, it's running through those cyclic voltamographs, and those peak heights is what is determining how much capsaicin we do have in our sample, and the area below the peaks. So for this one, if this one is more pungent, if this one got more capsaicin, we would expect the peak heights to be higher. So there's quite an exact science and a cool science behind it. And we've just simplified it, put it into an app which is easy for people to use, and look at the results and get a result straight back. So we're doing that conversion for you. So now we're getting a result back, and this one comes back as 54,000 Scoville heat units. So you see that's quite a lot more spicy than the one we did for Tabasco.
Okay, great. Thanks, Solron. I think you slightly
2 different ranges of Scoville heat units.
All right, brilliant. Thanks, Solron. Appreciate it. So as you can see, we definitely do these webinars live. That's why we leave in the deliberate mistakes, not mistakes, but the deliberate bandwidth issues. So what I want to say is now we do people who are interested in the FoodSense, we do this, these live webinars every month. We try to show a mild something, and everyone scoffs at Tabasco sauce, but it's a mild one. And, you can find in the public domain, what the hot heatness is meant to be, so you can kind of validate it. And then we do something that's a bit more pungent. In this case, this month we did the chili powder, but you can also do the chili peppers as well. We have done de bomb, etc. On this system as well. We do have videos about that. And also, don't forget, there's actually this will be a repeat. So for you guys who are attending today, I wouldn't be too concerned, but there is a webinar on the 22nd of August, which will be a sort of repeat of this. We do one in the morning and one in the afternoon to try and cover all the time zones. So if you've got any questions, you're probably in contact with myself or Niti. Otherwise, we will send you out a link later on with a recording of this, so you can sort of watch it or share it with colleagues. Okay, so I want to say thank you to Niti for organizing this today. I want to say thank you to Solron for doing the live demos. It's always fun, I'm sure. And I want to say thank you to yourselves for attending. And as I say, reach out to us if you've got any questions. And if you want to see this again, we'll do a live demo on the 22nd of August. Okay, thanks very much, Solron. Thank you, Niti. Take care, guys.